To help you calculate specific heat using calorimetry. I'm going to use the Gizmo Activity C, question number 1, to walk you through how to do this. So when you mix two substances, the heat gained by one substance is exactly equal to the heat lost by the other substance. This is a really, really, really important statement that you need to make sure that you remember. We're going to get into that in a minute. All right. So this question says you're going to place 125 grams of aluminum in a calorimeter with 1,000 grams of water. The water is going to change temperature by 2 degrees Celsius, and the aluminum is going to change temperature by 74.95 degrees Celsius. So you'll notice that the negative number here, that's just saying that the temperature is going down for the water. We're going to ignore positive and the negatives to make our math a little bit easier in this. Okay. So for A, it's going to give us some information that the known specific heat of water is 4.184 joules per gram per degree Celsius. That is going to be our C. We want to start using joules now instead of calories because it's more accurate, it's better, it's a little bit more precise number. So we're going to use Q equals MCAT to solve this. I always like to say all my variables down here. Q is what I'm looking for because it says how much heat energy. Q is what I'm looking for. So I need to know the mass of the water, the specific heat of the water, and the change in temperature of the water. This is very important that we're doing this for water. All of my substances, all of my numbers better be for water. So the mass of the water is 1,000 grams. The specific heat of the water is my 4.184 joules per gram per degree Celsius. I'm going to write out the whole unit. And then the change in temperature for the water, it says the water changes temperature by 2 degrees Celsius. I don't have to subtract this time because it's literally giving me the change in temperature. Be careful about that when you're solving other questions. Okay, so literally all I'm going to do is I'm just going to plug in the formula. Q is what I'm looking for. M is 1,000 grams. C is 4.184 joules per gram per degree Celsius. And delta T is 2 degrees Celsius. I could write 2.00, but there's really no point. Do that in your calculator. Pause the video, double check your work. When you're done, you should get 8,368 joules. How do I know that I get joules? Because grams cancels out, degrees Celsius cancels out, I'm left with joules. Also because joules is energy. So this is the amount of heat that the water is absorbing. Okay? So that should be something you know how to do. But now what we're going to do is we're going to solve for the specific heat of the aluminum. In order to do that, we have to recognize that the heat gained by the water is equal to the energy lost by the aluminum. The heat is the same. The energy is the same. It is the same energy. So this heat is the same energy that the aluminum is going to be doing. I'm going to use exactly the same formula. Q equals MC delta T. But this time I'm going to do it for aluminum, which means all of my numbers better be for aluminum. This time I know my Q, I know my heat. It is the same that the water absorbed. M is the mass of the aluminum. So in this case, it's 125 grams. C is what I'm looking for, so I'm not going to know that. And delta T is the change in temperature for the aluminum, which is 74 74.95. So I'm ignoring the negative because that's just telling me that the temperature is going down. If I didn't ignore negative, then I'd have to show that the Q was negative as well, meaning that it lost heat. But our number is going to end up positive in the end, so we're going to just ignore that for now. All right, so there's two ways I can solve this. I can actually rearrange the formula to solve for C. If you're good at algebra, you should be able to do that pretty easily. Or I find that most of my students, that confuses them for some reason. So what I'm going to do is I'm just going to plug in these numbers exactly the way it's written. So 8,368 joules is my Q, equals, don't forget that equals, 125 grams is my mass, C is what I'm looking for, and my delta T is 74.95 degrees Celsius. So I literally just put in Q equals MC delta T, just replacing my letters with my values. And now it's just an algebra question. So in algebra, what I'm going to do is I'm going to get rid of, I want to isolate that C. So I'm going to divide both sides by 125. That's going to cancel this out. Divide this by 125. Okay, well, and that's going to give me joules per gram on that side. So 368 divided by 125. So I will end up with, on this side, 66.944 joules per gram. I did not round. Do not round until the very end. And then the other side, I still have 74.95 degrees Celsius times C. I'm going to repeat that same process. Divide by 74.95 on both sides. Degrees Celsius. And when you're, so I just leave the number on my calculator, divide by 74.95, and I'm going to end up with C is equal to 0.893 joules per gram per degree Celsius. If those units confuse you, how they end up like that, please see Mr. Dren. It's easier for me to show you that in person. And that's how you do the work. The key idea is you are always going to first find the heat for water, and second, use the heat for the water as the heat for the metal or whatever substance that you're finding the specific heat in Q equals MCAT. The difference is now you're solving for C instead of solving for Q. And that's it.